All right, good morning. Here we are, BC Calc. Good morning. I don't know, maybe the world.
Wait, are you live streaming?
Yeah, I am right now. I didn't do that the other day because I hit the wrong button, so that was not good. So, does anybody have their graph that they can share with me and bring it up? Because I have a blank one.
First one?
Yeah.
Sure. I'll look at it.
So this is the graph you should have had, something like that. And Olivia, I'm using yours, right?
Yep.
What do you know about when you used the difference between the first table, which is up here, and the second table, which is here?
Well, since it's the same path, it ends up being the same line.
Okay, because you can't notate what?
Speed.
Right, the time on here.
Yeah.
Right, would everybody agree?
Correct.
All right, so let's flip it over to the other side.
I have a question.
Yep.
So, like, what do people call, like, you know when you're counting and you go, like, 800, 900, why don't people say 1000?
Some people do.
Do they? I've heard, like, 1100, 1200, but I've never heard anybody call it 1000.
One time in middle school shop class, I tried to say 2000 and everyone laughed at me.
Sounds like a you problem.
Wow.
Olivia, you want to take this back? Okay. So, did anybody have a different graph than what you saw up there? Anybody try to do it a little bit differently? All right. One thing you would add, what would you add if you wanted to give the direction over a period of time? Yeah.
I don't know if this is right, but I feel like you would add like a velocity graph.
Okay, what about to the graph that you created? If you want to say, all right, they're moving in this direction. Yeah.
You'd add an arrow.
Right, you could add a series of arrows or an arrow, just one arrow that says, hey, this is where we're started and this is where we're headed, correct? All right, so what we're leading up to is parametric equations, and there is a spot where there's a summary. Oh, we also had this dropping of keys. Am I right? You want to share that with me, Olivia, since you're on a roll here? And you have a color coordinated and a key. So those were, you made these columns. And so here's your vertical component. And so here is your graph. And this is dropping straight down, correct? And then these are with the winds. And so you got those graphs. So that's very good. That's the same graphs that I have. All right? So I'm going to flip it over to the other side. And the question is, I'm on number 7. When do the keys hit the ground in all 3 instances? Do they hit at the same time? Okay. And who said, Sean, you were gone, right? Yeah. Taurus, you were here, right? And you did a physics, Olivia can take this. You did a physics presentation last year, right, with Sean?
Right.
Okay. And so what can you conclude from, it says, when do the keys hit the ground? What can you conclude about the horizontal force acting on an object and how it affects the vertical distance? What can you tell me? It doesn't, okay? In fact, if you look on Schoology, I put 3 videos on Schoology that you'll need to take a look at. Well, 2 for sure. You'll have to look at 1 for sure, I guess. One of them is Mythbusters, and what they do is they shoot a bullet from a gun. I think it's like a pistol. And they drop the bullet at the same time. And then they do the elapse and take a look at when both bullets hit the ground, and they're within 10,000ths of a second that those bullets. So the horizontal doesn't affect the vertical at all.
So if we had something different, should we change it?
Oh no, you could just write down your opinion. more curious about how you think. All right, so in the summary, these are the four things I want you to put down. The first one is we're working with something called parametric equations.
Do you just want bullet points?
Yep, I'm just creating 4 bullet points. And what happens is the horizontal distance and vertical distance were both dependent upon time. All right. The second thing is we have time is called a parameter. And so you're going to see us write things like this: x of t and y of t. And this is going to be our horizontal measure. And this is going to be our vertical measure. And a parametric equation it doesn't always have to be time, but time is what you're going to see the most of, and that it is the variable that causes change in both the y and the x values. All right? And we have something called direction. And direction is going to be called orientation. And we use arrows to show orientation. I didn't give you your test, did I? I was going to do that. Do you want your test right now? Let me finish this up and I'll give it to you. Okay? And I'm talking at Haley.
Oh, okay.
Okay? And the total elapsed time is not on the graph, but in the table. Okay? So I'm going to go give you your notes, and I'm going to give Haley something right here that I forgot to do.
Do you want us to keep these under here?
What?
Do you want us to keep these or throw them?
I want you to keep them for now. And I'm going to give you this. That's what we're going over. What is your breakfast?
It is good.
What do you call it?
Chicken, Thai chicken curry flatbread.
Does that got feta cheese on it?
Cream cheese.
What?
Cream cheese.
Cream cheese. It would be better with feta cheese on it?
It wouldn't be bad. I don't know if it would be better. I'm a cream cheese guy myself.
I don't like cream cheese.
I like feta cheese.
Me too. I love all cheeses. I love all cheeses.
You ever had a
Cream cheese.
Blue cheese?
Oh yeah.
Alrighty, so here are the notes that I gave you. We're only going to cover 2 sections on this. So I'm hoping to finish up with parametric equations today, the base part of it, and then we're going to take a look at derivatives of parametric equations tomorrow. Wednesday is DECA day, am I correct?
Yes. Yep.
Okay, and band day. Okay, and so we'll have a quiz on Thursday, but it's primarily going to be a work day on Wednesday. All right, so here's a graph of a parabola. And here's its equation. And so the idea of a parametric equation, as a point moves along this line, or some type of object, I can say that if it starts here and moves in this direction, it gets there over a period of time, till it finally ends there. All right, so I could take a look that some type of object could follow this path. And from the time that it started at the origin here to the time that it came back to the x-axis is a period of time. And what I did is I created a table and I made up a time. And I said, all right, my domain is going to be from 0 to 100. In other words, it took that amount of time to get from the origin here to this place on the x-axis. And right here I've defined my x variable and my y variable so that it's dependent upon that time. So if I want to know what the x values are, all I did was put in 0, 1, 5, 10, 40, 50, all the way up to 100 into this equation to come up with my x values. Likewise, I came up with this equation for my y values, and I just made them up. And when I plug those in, when I plugged in that time, those time values, that's what I got for my y values. And so you could see at 10 seconds, I was at the point 1, 9. At 60 seconds, I was at 6, 24. Is that kind of making sense? So the points are generated by the time that you're given. All right, so let's look at the next page. So I created 2 more. And my domain for my time is from a -2 to 3. And I just chose some type of values. And then I generated the points of x and y by putting those values in there. So if I were to plot these, I would plot, first of all, my point would be 0, -1. My next point would be -3, -5 about here, or -0.5, and -4, 0, -3.5, 0, 1, and then 5 and 1.5. So if I to draw my graph would look like that. That would be the path of that object. And if I put these arrows in there, I'm giving it its orientation. So you know where it started, where it ended. Yes, sir.
So say the order that so say it went 5, 1.501, then it would go the other way?
Correct. Okay. Yeah, and I might have started at 0 and go from 0 to 5. All right. And if you look on the videos where they show you how to use there's 3 videos. One is the Mythbusters video that I talked about. That's on Schoology. The other 2 videos is if you have a Casio, how to create parametric equations with your Casio. If you have a Texas Instruments, how to create parametric equations with your TI. So those are both on there. They're about 2 to 3 minutes long. I think they're very helpful. I think it's easier on the Casio, but they do talk about what the values, how you can adjust for the values of time. Because it does. When you graph it on your calculator, you tell this portion in your calculator where to start, where to end, and it graphs just that portion for you. Does that kind of make sense? All right. So what I want you to do now is I'm going to give you a few seconds to complete this table. Here are your 2 parametric equations. Here is your domain for your time. And then what I want you to do is graph them and determine your orientation. And I'll give you about 3-4 minutes to do that. And I'm going to kind of fool around with my computer as I'm doing that.
Mr. Kruger.
Yes, sir.
I'm gonna fill my water bottle.
Yeah, sure can. There I go. All right, we have some values, am I right?
Correct.
Okay. Flora, you want to tell me what you got?
Okay.
Let's go across the x's first, okay?
Okay.
Okay.
So 5, 0, negative 3, negative 4, negative 9.75.
Is that right? Negative 9.75? Oh.
Negative 3.
Negative 3.
Got him. Right. And then 0.
0?
Yep.
Okay. And then, Carter, you want to give me the y's?
1.5,
1.5.
1.5, -0, negative 0.5, negative 1.
Everybody agree with that? Okay. So let's see. 5, 1.5. I could approximately there. 0, 1 right here. Negative 3.5. Negative 4, 0. Negative 3.5 and 0, negative 1. So it kind of looks like this. Does that seem correct?
Correct.
So there's my orientation. Does that kind of look like what you have? All right. Okay. So, and you'll see that on your calculators. They'll draw those exact things. And if you watch the videos, they'll tell you how to restrict your t values. Okay. If you take a look on your calculators where you enter your variable for x, you'll see that there's a t in there, and you're just telling it the type that you want. Okay. That's the part. All right, so converting parametric equations to rectangular equations, what I usually do here is I take one of the variables and I solve for that variable, or excuse me, I solve for t. So in this case, I usually use x. I can say that 10x is equal to t. And so then what I do is I take that expression that I have in terms of x and replace it with t. And so I'll have 10x minus 10x that's squared over 100. And so I'll have my rectangular equation is going to be 10x minus x squared. Does everybody see where that comes from? And this graph should look like that parametric graph. Yes, ma'am.
So if you can convert into a rectangular equation, why do you use parametric?
Because we're going to look at some application problems further in the notes, because we then can determine where our location is based on a moment in time. Okay, so one of the famous things that, you know, mathematicians were part of in the early parts of hi, how are you guys?
Got your podium
My podium.
from Mrs. Bamboom. She said that you would be happy with this.
Yeah, I would love that, but why am I getting it?
Why do you want a podium?
Well, I want it for induction. That's what I usually have. She's just giving it to me?
Yeah.
Oh, well, you know, behind the door there's those shelves, and there are things sticking out there, which I don't know what those are.
Spears.
Yeah, spears. We do some spear throwing in here. Can you set them up? Can you set it on top of there?
Try. An
You
analog.
gotta show the lights.
Can you reach that high?
Here, then have a little, it's a sphere. Stick with a-
Yeah, and then, thank you very much. Thank you for that. It's unexpected.
Okay, do you want to play Gabriel's horn for us? Okay, play for us.
Sphere. It's called an analog.
Alrighty.
I have
Okay.
seen those.
I've used one. I was really bad at it.
So, ballistics was a really big part of mathematics. And so, if you're going to shoot a cannonball and you wanted to hit a particular location, you had to know what moments it was in the air. And so that was the beginning of parametric equations. Does that answer that?
Yes.
Okay, and also if you do some videos, you get some really nice, cool graphs of different types of graphs using parametric equations that you can't do with rectangular equations with simply x and y. Okay?
Okay.
Alrighty. All right, so I will ask Abby, tell me what to do here. Which variable would you choose?
Why?
Okay?
So you just have to times by 2. So it'd be t equals 2y.
Okay?
Oh, continue. Okay.
Mm-hmm.
So it would be x equals 2y squared minus 1.
So that gives me x equals 4y squared minus 4. Is that correct?
Yep.
Okay, so we got to get y by itself. You're on a roll.
Yeah. Okay. So it'd be x plus 4 divided by 4. All of that cubed. That's cubed. Squared. That's what.
Plus or minus square root, right? Or it might look like this. Plus or minus 1/2 the square root of x plus 4. Okay.
By 1/2. Just kidding.
Okay.
Gotcha.
Alrighty. Emma. X equals, I bet you could tell me. What's t going to be over here?
T is going to be negative y
Okay, can I write it as 1 minus y?
So then x equals 4 times quantity minus y squared minus 8 times the quantity minus y.
Perfect. You want me to multiply that out for you?
Yes.
1 minus 2y plus y squared, I think. Am I right? Minus 8 plus 8y. Now, when it gets complex like this, I would just probably leave it in terms of x. So you're going to get 4y squared. The y's are gone. Maybe you will be able to solve it. And I get minus 4. Is that what you get, Emma? 4 times y squared is 4y squared. 4 times the negative 2y is a negative 8y plus 8y. And then 4 times 1 is 4 minus 8. I guess I can get y by itself. So I think we're going to get exactly the same thing, aren't we?
Yep.
Right? Now y is going to equal plus or minus 1/2 the square root of x plus 4. Now the reason I chose these is because you have two different sets of parametric equations that represent the same rectangular equation. Does everybody see that? So if you notice the next directions, it say converting rectangular equations into parametric form. You can have more than one answer. And example, one of the ways I can do this is the easiest way is say x equals t. And so then y would equal t minus 1. That would be one set. Or you'll see it also written this way. X of t is equal to t, and y of t is equal to t minus 1.
Would it be 2t minus 1?
Oh, excuse me. Yep, 2t. Thank you. I was thinking ahead. Another set you could do is say x is equal to 2t. So then y would be t minus 1. That's what I was thinking. So you see how I can have two different sets? Okay. Then over here, I could do the same type of thing. I could say x equals t, and then y is going to equal t squared plus 9. That gives me one set. Or I could say x equals t squared, and then y would equal t plus 9.
Wait, can we go, so for the bottom one and the one before, the x equals 2t, why would y equal
T plus 1.
t minus 1?
T minus 1, yeah, why?
They're substituting
What if you substituted in one to be?
Oh, I would want, it would be 4t minus 1, wouldn't it? Correct?
What?
Yeah.
How did you choose x equals t and x equals 2t?
I just made them up. Okay? And I could also do this. I'm going to make a third one. Okay, you ready? I could say this. X is equal to 1/2 t. And then this would give me, when I plug x into here, I would get 2 times a half of t. So here I would get t minus 1.
So you can make x into whatever.
Whatever you want it to be.
So you could really have like endless.
Right. You can. And so this one I did incorrectly. This one's okay. This one should be t to the 4th plus 9. Okay, because if I say x is equal to t, and I see I have to square x, wouldn't I have to square t? If I say x equals t squared, and I'm squaring x, wouldn't I have to have t to the 4th? And I could make a third one. I could say x equals the square root of t. Again, Emma, I'm just making them up.
Okay.
Then y, because y is dependent upon x, right, when I create that equation. And so I'm making x dependent upon t, and then I'm substituting that value in for x. And so in this case, I'd get t plus 9. Jaden, what What's your question?
So on the quiz, we're gonna have to know how to convert into rectangular form and convert rectangular form into parametric form.
Right, and I would just ask you for 2 sets.
Oh, so you have to do 2 different ways of doing it?
Right, like here. Okay.
So for each problem, you can do infinite.
Oh yeah, you can come up with an infinite. Easiest way is just say x equals t. Yes.
Do we, so for the last two, 5 and 6, do we have to determine the correct sign?
Correct. Yep.
Okay.
Yeah, you'd have to. Here you have.
No, for the other two. Examples 5 and example 6.
Like y equals.
Oh, right here.
Yeah.
Yeah.
So we have to determine the sign.
Well, no, you don't know what it is.
If you plug a value to t, though, can't you find out?
Yeah, I suppose you could. Yeah, because you know this, right?
So do we have to do that?
No,
I'm getting over.
I would just want this general form.
Okay.
Okay, because you know the equation you came up with is part of this. You see what I'm saying? Okay, because depending on what you put in for t is going to decide, am I graphing the positive version of it or the negative version of that? You will see that especially on the Casio version, because it's not the same guy doing, how to use your calculator. So what you depend on t will depend on what part of your graph. Like on this right here, if I would have started here, I would only have gotten that upper portion. I wouldn't have gotten the lower portion. Does that make sense?
Okay.
So when you give me this, I'm assuming for whatever t value you want. Okay? All right, so this we could say what here?
X equals t.
Let's just come up with one of them. What would you choose?
X equals t.
You would on this one?
Y equals t.
Why would you choose y equals t? Why would?
Y's the one in the column.
Yeah, x happens to be dependent upon y here. So yeah, you could say y equals t, and then x would be the square root of t plus 1.
Wouldn't it be t cubed?
T cubed plus 1, thank you.
That's fair.
Mr. Kruger,
Yep,
what's your favorite color?
Not green.
I don't know what it is. I thought it was green, till you guys told me last year I said not green.
You did.
Last year said I don't like green.
All right, so D is exactly the same thing. So what I want you to do is find 2 sets of parametric equations that represent this graph, and using each of the following parameters. It doesn't say what parameters, okay? So you can just cross that out, and we'll determine the orientation of the curve. So Jonathan, give me one set of parameters.
X equals t. Y equals t squared.
Okay, and what do you give me? What you want t to be in between? Give me a range for t or a domain for t. 0 to what? All I heard was 0, and then I heard the pencil sharp. 10. Okay.
Does it matter what the range is?
At this point, no. Okay. So
Can we make it as small or as large as we want?
you can, yeah. You'll see there'll be certain questions you'll say, hey, I want to make it to this fashion, and I'll show you that in a bit. Okay?
Is there like a certain number of intervals you're gonna want it on? So like if we do like the range from like 0 to 1, when we like multiply.
Right, and they're going to talk about something called a pitch. So if you're going to go 0 to 1, you're probably going to your pitch probably is going to be point something. And so to me, 10 is pretty high if I got to plot a lot of stuff. So we're going to go from 0 to 10. I'm probably going to have a pitch of 2, because if I get 5 points, I'll not only know what the graph is going to look like, I'll know the orientation of the graph. I don't have to plot all 10 points. Does that make sense? So what I would do is I would start at 0 because you know that's your starting point.
So like on these ones, we get to determine the pitch.
Correct. Okay? And so you can see I'm going to have 0, 5. Then I would probably jump to 2.
That's 4, isn't
And that's going to be, pardon?
it? That is, that's
You counted 4 lines.
4.
A whole.
5.
What a rebel.
Okay? And then you're going to see you're going to have 2, 9, correct?
I did not make this big enough.
Yeah. Well, this is where 2, 9 is going to be.
Just gonna keep it big.
And then it's going to be 6, what, 41?
Oh.
So you can see this is the shape that it's going to be. So in this case, Abby, I would do 3.
Okay.
Okay?
Well, then would you change the interval then?
Yeah, probably, yeah. All right, so here's another one. Here's another very common one. So rather than time, you have an angle measurement. And you can see right here, they give you your range or your domain of theta. And it says sketch the curve represented by those. Well, sometimes it's easy to, it says solve for cosine theta, sine theta. So in other words, I get x over 5 is equal to cosine theta. And y over 5 is equal to sine theta. So anytime I get sine and cosine, that's the first thing I do. And I always use this identity. So you should see that I get x squared over 25 plus y squared over 25, and that equals 1. So I get x squared plus y squared is equal to 25. And what shape is that? Circle. So when we start at 0, we're starting right there because the cosine of 0 is 1 and the sine of 0 is 0. So then if I put in pi over 2, this is going to be 0 and this is going to be 1, correct? So it tells me that my orientation is this way. Again, same type of thing. I've been given sine and cosine. So I have x over 4 is equal to cosine, and y over 7 is equal to sine. So if I plug those in, same type of identity, I'm going to get x squared over 16 plus y squared over 49 is equal to 1. Does anybody know what that shape is?
An ellipse.
It's an ellipse. Exactly correct. Okay, so I'm going to draw an ellipse.
How do you know how to draw it?
Okay, that's a great question. Okay, so this is what the way I do it. So it's either going to be elongated vertically or elongated horizontally. Does everybody understand what I mean by that?
So is it just like an oval?
Pardon?
An oval?
Oval and an ellipse are the same thing.
Okay.
Oval is a lay person's name for an ellipse, like circle is a lay person's name for a circle.
What the? Show it to my girl.
Okay, so this is what I do. Okay, if I make x 0, what does y have to be for that to be true?
49. I mean 7.
7 and negative 7, correct?
Yes.
Okay, so here's 7, down here, here's a negative 7. If y is 0, what does x have to be?
For negative 4.
For negative 4. So you can see it's elongated vertically.
That's so much easier than how
Plus, you can also see what's nice about parametric equations. You can see that an ellipse and a circle are related in some fashion, aren't they?
Summed up like 2 weeks of math.
Pardon?
I said you like summed up 2 weeks of math.
Right. And do you remember? Did you remember talking about conic sections?
Yeah.
Okay.
You made it so much
Okay.
simpler.
And to me, you have these points right here. Okay. Do you know what those 2 points are called?
Oh, I know them. Crumbs?
Close. Really
Well,
close.
that, or is it, that one's the one in the middle.
Okay.
Full.
I thought they were called foci for a long time too, till I was corrected by a medical person because they're important in medicine. I don't know why. They call them foci.
Oh, shy.
Yeah.
Faux shy.
And as you move them this way,
Faux shy.
it gets less elongated. Does that kind of make sense? So a circle, it's really where those foci are the same spot.
So when the foci.
Yeah, it's something called eccentricity. Did you remember? Yeah, eccentricity is 0, which has big applications dealing with physics and orbital when things move through. Okay,
Well, just wait till you take
I'm getting too far out there, aren't I? I'm sorry, Alex. Okay. All right, backside. I think this is pretty cool.
Baseball. Baseball.
So these are actually 2 things you're going to have to be able to keep in your notes and be able to refer to. These are parametric equations dealing with a projectile motion. So something that is launched. Okay? And notice what's put in here is cosine and sine. So that's something that's relatively new. V sub 0 is still your initial velocity. And this is your angle of what we call inclination. Does everybody understand what angle of inclination is? Okay, so you have a horizon. Okay, so this is right here. This line right here would represent the line that is headed towards the horizon. This is your angle of inclination. How far from the horizon it's going up. Does that make sense? Okay? Or your horizontal angle. So, it says a center field fence is 10 feet high, 400 feet from home plate. The ball is hit 300 feet above the ground. It leaves the bat at an angle of theta, radians, and actually I want you to put this, I found out it's a lot easier with degrees. And every problem that I've seen so far has been in degrees. So that's one typo I did not fix. At a speed of 100 miles per hour. So, my parametric equations, x of t. Alex is what? You gotta be careful here.
Can't it just be T right now? Does that not work?
Okay, do you see this up here?
Yeah, that's fine.
And notice this, just a couple of things. Height in feet, angle in degrees, velocity has to be in feet per second. So what's my initial velocity? No, it's not 100.
0.
It's not 0 either.
Initial velocity. Oh, no.
If it was 0, it'd fall straight to the ground.
Alright, that's not.
Okay. And this ball is actually going somewhere. Deva, any ideas?
So wait, we said it's not 100?
It's not 100 miles per hour, no. Because it's miles per hour.
Right. I don't know how many miles are in a foot or how many feet are in a mile.
You don't?
It's like
Does anybody know?
5,000.
5,280. It was a requirement of Kruger Welding. So 5,280 times 100 divided by how many seconds are in an hour? No, it's 60 minutes are in an hour.
3,600.
3,600.
That's
I think you get what?
How many?
Why are there so many zeros?
Because it's
3 times it by 100.
Oh, okay.
Okay.
This is 146.
146 and 2/3, correct?
Yeah.
Yep.
So you
Are
have,
you videotaping right now?
yeah,
Okay.
yeah. Well, I'm not videotaping, I'm streaming live in the abyss.
You scoot it over.
That's what I call it. Oh,
Wait.
that better?
There we go.
And you said 0.667, correct? Okay. Times the cosine of theta times t, correct? Okay. So y sub t, the horizontal component, that's this right here.
Wait, why is the horizontal? Okay, yep.
X sub t is the horizontal. Y sub t is going to be the vertical.
Okay.
Okay? And so it says it is, my initial height is what? 3 plus 146.667 sine of theta t minus 16t squared. So, we might as well learn our calculators, okay? So go to your y equals. How many people have TIs? Okay, so if you got a TI, you got to go to mode. And do you see on mode where it says parameter?
Like function, parameter, polar.
Yeah, where it says function, parameter.
Oh, yeah.
Yeah, you want to go to parameter.
Like B8.
And Casio people, you want to go to type.
Do we want to change it from radians to degrees?
Yeah, change your radians to degrees, yep.
In the
You can
graph.
turn it over to
Huh?
Is that one for
No, in the,
the numbers.
what do you have, a Casio or?
I don't know when to be
Casio.
Why don't you bring your Casio up here? Casio's a little bit, so you go to graph on your Casio. This is what you're going to see in the video. So if you choose that, you have a thing that says type right here. So I'm going to choose type, and there's your parametric. So as soon as you do that, you get x of t, y of t. So you can put a whole bunch they have to come in sets though. All right? So everybody have something like that? Were you able to do that on TI also? Were you able to do that on TI or no?
Yeah, kind of.
You go to mode,
Parametric degrees, but then like where's
Hit Y.
y equals?
and then go to y equals.
Okay.
Is it on there?
Yeah.
Okay.
So I got the second one right.
All right.
Checked it.
So
That's what I got wrong.
on y, I'm going to type in 144.667. What'd I say?
144.
Yeah, 144.667.
It's 146.
Oh, it's 146. Oh, I got to make sure you're in degrees. I didn't do that. All right, I got you back in degrees, Emma, okay?
Okay.
Let's see, that's just what I got right. That's what my problem.
cosine of what? 15 degrees? Isn't that the first one? And I think I better put in parentheses.
How, where, what are we doing?
We're
I
doing
think
B.
I missed.
Abby, B.
Oh, wait, what?
B.
From B. Letter B.
Okay.
So what do we
Okay. That goes.
Oh, I think I know.
Parentheses.
That's the worst.
Oh, yeah. Wait. This is so
Okay, so I got the two equations.
Will you
No.
go back to the second one so I can see the?
Yep.
Oh wait, never mind. It was. Never mind. That's all I.
Then do we graph it?
Yeah, I'm going to set my window though. I'm going to go from 0 to 400. You see why I choose 400?
Wait. Okay, so don't mess with the T.
Yeah, I'm going to go all the way down there. All right?
Okay.
And I'm going to go from 0. Oh, I'm just going to choose 50. And if you keep going, right here is your, for you it says T on TI, right?
Yeah.
Okay, on Casio, it doesn't. So I'm going to go from 0, and I think I'm going to pick, I'm going to pick 5. I'm going to start out with. I think that works. And then I'm going to have a pitch of 1.
Is pitch the same thing as T step?
Yes, it is.
Sounds like no.
Okay.
Here.
What does that mean?
T step.
Oops.
So on a Casio, the TI is just that.
Is this supposed to be like?
No, ignore that one. And then go 0.
0 to
Wait,
4.
and go down.
The
0. And graph.
I wonder if I have 0.1, if it'd be better.
Wait, what should our T step be?
I choose 0.1 and see what happens.
0.1.
Wow. Mine literally looks like a line.
Mine literally does not have.
Does yours look like this?
No, mine's round.
Mine looks like a straight line.
Mine is non-existent. Wait, can you go back to your window? Down. Left. Yep. Should I be, if we're going from.
Oh, I want this one.
So, we're going from 0 to 400. Yeah, why 400?
There we go. Yeah, why 400?
400 is a home run.
Mine does not look
400's a home run, isn't it?
I guess. Okay.
Mine looks like a straight line.
But like, mine, there's nothing, there's nothing.
Okay, I don't know what you did.
Okay, because you forgot a T here. I did what you said, I think.
I don't think so.
I don't, what are you doing? You're gonna, it's this equation.
So the question is it a home run? Wow, how do you know that?
He set it to 400 and it didn't make it to 400.
So if I trace, right, and type in 400,
You just grab a T.
Nice.
oh, that's 3.
Okay, wait. So oh, that's Casio. How do we,
Why did you choose 300?
so wait, what do we do?
I don't know what he's trying to do.
I'm trying to trace here. So here's my graph. So you can see at 1 second, I'm at 141 feet. Right here is where I'm at the top, at about 1.2 seconds. So I'm just tracing. And at 400 feet, if you take a look, it tells you that the height of the wall is 10 feet. So right here, y is my height, isn't it? So here I'm at 14 feet, I'm at 283 feet.
Did you even make it to 400?
Were we supposed to put in the like times T and the like minus?
I typed in the equation, that's what I did.
Yeah. pop up.
So you can see right there at 311 feet, I'm below the fence, aren't I? Okay?
But it doesn't even make it 400.
It doesn't make it 400, does it? So now I'm going to exit, and I'm going to change this, and I'm going to change this to 23.
It's so up and down that it may be a home run, but once you get out of the telephone.
And I'm going to draw it now.
Yeah, it's good.
And so again, I can trace. And so there's the flight of the ball. And I'm looking to see what the height is at 400 feet. So I'm at 41 feet at 354. At 405, I clear the fence at 30 feet.
Yeah.
That is
That's a dinger.
yeah.
That's a big home run.
That's a big home run.
Okay?
Huge.
So the question is, on the next one, what's the minimal angle have to be? How would you figure that out? Well, you know it has to be between what?
15, 23.
Yeah, 15 and 23. So Emma, I'm going to hand this back to you. Okay? And that's what I want you guys to figure out now, and then I'm going to hand out your assignment. And I got 2 sets of an assignment. I'm not doing any assignments in the book for Chapter 10.
Okay, so 15 and 23.
I'm very specific what I'm going to choose.
So it's pretty much just like a plug it in.
Yeah, I think so. I think so. So
you
what?
have to check all of them?
Well, okay. You know 15 is too short, correct? And you know 23 is enough. So where would you start?
I think you found it.
What is it?
And you give me the nearest whole number.
Okay.
Can you put that away?
I can.
Okay, please.
Yes.
Okay. And today we don't have a calculator?
Nope.
Okay. And it's somewhere?
Ooh, somewhere.
At home
Or in my car.
or in your car?
So,
Which is the hardest to search through?
That's a dinger right there.
can you clear it? All of them, because I seriously lack motivation.
Okay.
Well, you have to make sure that
I
it
just
is
did.
400 feet where it's above 10.
Wait.
Yeah, it's got to be,
Oh, no.
it's got to, your Y value's got to be bigger than 10.
Shoot.
Because
It's not 19.
So what do you
I
have?
think it's 20.
20?
20 degrees, because it's at,
What about 20.5?
What about 19? Will it work at
No.
19?
19 does not work.
so then we just put the nearest whole number.
Great. Okay. All right, let me give you your assignment.